Charging and discharging of capacitors. State physical meaning of time constant. Use tau equal to RC. Sketch and explain the characteristic of QT and IET graph for charging and discharging of a capacitor. Use equation for the discharging and charging. Determine the time constant of an RC circuit by experiment 1 capacitor. Charging and discharging of capacitor. We will start with the definition of time constant. The symbol is tau. For the charging process, time constant is the time required for the charge. So the symbol should be Q on the capacitor to reach 63% of its maximum charge is Q0. So the keyword here must reach for charging process. And then for discharging process, the time required for the charge decreases to 37%. So the keyword should be required for the charge decrease to 37%. Time constant, the formula is tau equal to resistance capacitance. Unit in second. Or sometimes we can use the symbol small s. Next, from two different diagrams, so look at the charging mass has battery. So here, battery here to show charging process. And then without battery here, show discharging process. Now, during discharging and charging process, look at what happened to the voltage. What happened to the voltage across capacitor here? Okay, so we can label as VC. And then the charge on the capacitor here. And the current flow through the resistor. Means what? Okay, so the current flow through the resistor here. So what happened? Okay. During charging, the voltage across capacitor increase, charge increase, but for the current decrease. During discharging, the voltage across capacitor decrease, the charge on capacitor decrease, and the current across the resistor decrease. From the information from the voltage, charge and current, so we need to sketch a graph of VT, QT and IT. Now, let me show you what is the meaning of time constant. So, for the charging process, so the potential different across capacitor must reach 63% from the V0, and then this value, this time taken required, we call as a time constant. But for the discharging, when the voltage decrease to 37% from the V0, so this time required we call as a time constant. So same with the charge. When the charge increase to 60% and the charge decrease to 37%. So this time required we call as a time constant. Okay. Let's say, okay, if the charge increase 50% to reach Q0. Okay. Same with this, decrease to 50% from Q0. When I label here, extrapolate here, this time required is still we call as a time constant. The question is for this time measure here, when the charge increase to 50% or reduce to 50%, so can we call as a time constant? Can we call as a time constant? What's your answer? Cannot. Okay, why? Why? Because of specifically time constant is a time taken when the charge increased to 63% or reduced to 37% only. So means what? So I just label this is T for 50%. This is T, not tau, but T for 50%. So last part, so I want to show you the equation for each process. So for the voltage, actually we just use for this equation only. So we just use for this equation. This is charging and this is equation for this discharging. Next, we want to discuss for the related question, charging and discharging of capacitor. A fully charged capacitor has 12 microfarad and a 6 millicoulomb charge. The capacitor has been discharged. So the keyword here is discharge. So make sure we choose a suitable formula related to the concept discharge. Through a resistor 100 ohm. Okay, number 1 is the potential difference across capacitor. B, the time constant for charging circuit. C, time taken if just 20% charge left. Left here means remain. So we need to use this charging. Okay. The solution, concept, discharge, and then the information given, capacitance, charge, millicoulomb, resistance. Okay, A, how to calculate potential difference? So by using C equal to Q over V, so we will get the answer 500 volt. B, to calculate time constant, so we use tau equal to RC, then we will get 1.2 times 10 to the power of -3 second. And then C, 20% charge left, meaning we want to determine the new charge when the charge 20% left from the maximum charge. So what is the time taken here? So because of the concept is discharge, so we use this equation and then substitute the new charge and then ln left hand side and the right hand side, and then this is the exponent. Actually this is exponent. So we will get this is the time when the charge 20% left.